Yeah, I think so. You guys hear me loud and clear, all right?
I can hear you.
Okay, cool.
All right, ready when you are, I think.
All right, cool, folks. Thank you very much for giving us an opportunity here to chat a little bit about the art of QA GitLab automation. Now, it was exactly that. We have a full tank of gas, half pack of cigarettes. It's dark. We were wearing sunglasses, and we're doing the QA lab. So, what we like doing is wreak havoc in a peaceful dev environment. Thanks, Corey. So we thought we'll share how. So, like one of the few things that we need to be mindful about, of course, is that there's plenty of QA efforts for Suricata already. So this is a new stream, a new effort, and we already are doing plenty inside the team. There's lots of people are participating. Tools, we get feedback from the community. We have feedbacks from setup in the wild. Again, from friendly community members, power users, and similar. But one of the things that we always try to make sure is 100% honest, like the releases. So we have lots of packaging QA around the releases when we have a new 5, a new 6, a new release in general. For the Windows packaging, the Ubuntu, JSON is taking care of the RPMs, for example. There's lots of accuracy testing going on via the Suricata Verify, which is maintained by JSON. There's some fuzzing done by Felipe. There is all sorts of privates and internals, QAs, setups, including Victor has one extremely private, for example, and things like that. And we have also live setups feedback, myself, Andres feedback from live deployments. Jeff also has actually given us a lot of feedback for SMB performance improvement deployments, and the Suricata community and power users already do that. So we had all that, but we needed to add something. So something was missing. What we tried to is wreak havoc in peaceful development environment. This is what actually we do. So let me, given the pleasure, please, to introduce the Sabotage unit of the OISF team. That's Mr. Corey Tomas, who will actually have the pleasure of actually walking your hands-on and speak about the QA lab, as he's one of the most hands-on men in there with the lab. And myself is Peter Manev. I'm sure most of you maybe have met me or I've met you. Unfortunately, I don't have the pleasure to meet you there on site now. Hopefully next year. I'm part of the OISF team. I participate both in QA and training, part of the executive council member, chief strategy officer at Stamos, maintain Selks. I brag a lot about Suricata. Corey, why don't you say a few words if you introduce yourself, please, if you don't mind.
Yeah, I've been trying to break Suricata, basically, the last better part of the year. And like Kelly said, I'm the newest member on the team. I'm glad to be here.
Cool. Thank you for your help. So what we really wanted was like to fully automate the process of gap coverage. So upon any code change, think of any PR, it could be public or private code change and similar things. We wanted to actually automate the heavy lifting and automatically notify upon failure. So in things like that, we usually what it means is that we actually need to have predictable and repeatable tests. In other words, if something crashes, we need to be able to reproduce it as many times as needed so that developers can catch it. And that needed to be for actually everything: performance, accuracy, you name it, ASAN leaks, seg false cordons, IDS, IPS modes, all that stuff. Live T-Rexes replay, or pcap, and and similar. So in those cases, we actually you need dedicated hardware. You need to basically sum up a bunch of different scripts. You need auto-notification capabilities. You need to be able to auto-run things. You need to be able to generate reports. All that should be actually automated, uploaded somewhere, so that it's ready to go. And we need to cover also Suricata 5, Suricata 6 releases. We need to cover any code that's going into master in general. So what does this mean? We had a few challenges along the road. So code security, not to mention, running malware pcaps in an environment, pulling off code from GitHub and similar things, different base branches. We need to how to figure out if that pull request is done against Suricata 5 branch or Suricata 6 and pipe it up for the proper testing. And then we need to, on top of that, send up the appropriate notifications on GitHub, on online chat systems, internal systems of the team, and similar ones. So to continue on the challenges that we had, we needed to, for example, not to repeat, if a PR was tested already, we shouldn't test it again before it's actually the code is updated, for example. Save that 100 gig core file if it appears and extract all the information from there so it's actually ready for the developer to use right away instead of actually having to rerun the test again and find it. Auto-tune the trex nick. So, for example, the nicks that we use for trex replay pcaps, every run they need to be, we need to just make sure they're running with the correct configuration and similar things at startup, at stop, cleanup, configs, and so on and so forth. So, plenty. Besides that, we shouldn't only really run auto tests. We should actually the QA lab should be available to the team to run a test when somebody from the dev team wants to run it. It needs to be able to work with any public or private repos. You need to be able to upload a tar of the code if you'd like to. It needs to work with our own internal coding if needed. Basically anywhere. The runner-up of these challenges here, I'll let Corey talk a little bit more about that, but the runner-up was for things that we meant to run in parallel but serially. And he'll talk a little bit about that because of specific challenges in there. For example, you have a trex run, but you need both the machines, so the trex and the Suricata receiving on the other end, and then but you shouldn't start really the pcap run before that, but you shouldn't start the next trex run. You should wait for Suricata to exit gracefully before this is done, and those sorts of things. So plenty to consider. The winner personally is actually when we do baselining and stats, when we update the OS and the network configuration, that actually affected the statistics that Suricata outputs, specifically for the trex, for example, just because some things did change. So there was no code changes either to the GitLab or to any of the PRs, and that sent us in a loop a little bit, but that was an interesting thing to find out, a lengthy subject in the advanced training for Suricata. So with full team and management support, I must admit, for sure, with all their blessing, we had a couple of months of QA and dev and brainstorming. Also, not to mention that our code review sometimes includes Linus Torvalds quotes. Then the GitLab in Boston was born. So there is a screenshot of actually the GitLab that is doing, or the last fail check in there, the one on top of the pipeline that is running is actually that fail check didn't pass. So a quick look, and special thanks to the CSU who provided the VPN gateway, Professor Ray Hansen, who was actually manually on site himself racking in, Jeff Lukowski, who actually provided good contacts for getting cheap hardware, and of course, Top Gun. So we had the QA lab running. So what we have now is about a pipeline that runs 51 job stages automatically. Each job can include one or more script runs and test executions. and checks for conditions, success, fail, and similar things, and notifies to the back channels like GitHub or the Mattermost in there. Next one, please, Corey. And so when we're talking specifically just purely of statistics, so you see all in the screenshot on the slide there, the different Suricata versions, from 5 to 6 plus master, and we have let's say a baseline that every PR is run against, and then we look for deviations. But that can actually also include, so in every of these runs, the stats log is compared, and every run is separate. So for example, this is running a TLP red pcap with AutoFP, but just in this specific test, for example, there's over 300 unique checks for the stats log if from the stat logs if it deviates from the base run. So for example, imagine you compare a pull request against Suricata master, and at the end of the run for this specific test, this is one of many, we compare all those stats. If one of them is deviating, we kind of need to pardon me, to raise a flag. So the current status is that we have actually something useful when running. Of course, we need to work more on it, and there's much things to be improved and fixed and further on. But actually, we have a good sort of automation done so far, largely, of course, thanks to Corey as well. And here you see a pipeline with some arguments running and similar things. So what does this actually mean? Well, in terms of performance, we have, so for example, we record perf-top, we do perf-top reports and records on a specific run, and then compare that to the baseline. So let's say the baseline means Suricata 603 stable, and we have a PR against Suricata 603 stable. So we compare the perf-top report that is run out there, compare specific functions, for example, rust and matching functions, if they deviate a lot from the baseline, for example, if they use more than 1% CPU, and things like that, or 1% more than, or 5% more than the previous test. So we need to know these things to understand what actually does this PR actually, how does this PR impact the run and the code. Time it runs, for example, if you're reading a pcap and similar things, does it take more time or less time? Having in mind that the hardware stays the same, all the tests stay the same, so that's stable. Memory deviations, we need to check that for both trex and pcap runs. And so, for example, just a small example here, if let's say we run a big pcap and we just sort out on the top 500, 1,000 signatures, and if, for example, for one unique signature, let's say, whatever that signature might be, if that signature has like 1% deviation of alerts between the baseline and the PR that's being tested, we would actually like to know why and what is causing this, having in mind that this is the baseline is being like, and something else that wants to be that we would like to merge actually introduces some sort of deviation. So all that automatically done, not manually. So if you have similar deviations, 1, 5, 10%. Now, talking about file extraction as well, we have 22,000 file extracted on some specific runs, and we need to make sure that over these about 22,000 cases are always the same, and when a new PR is merged, it doesn't affect that. We compare the checksums, the extracted files, and similar things, baseline versus PR. And we also need to be able to pass custom arguments during build, so we also need to take care of ASAN and segfault, so compile Suricata in such a way so that if there is a segfault, it could be a useful accordion, or pass any of your custom build options. If a developer wants to pass something specific, some specific flags, we can do that. Then all that needs to be covered, and we cover all that for IDS, IPS, netmap and NFQ in IPS is actually a work in progress. AF packet is there. NSM part of the Suricata engine, all the other protocol logs that produces that also we do tests on. So a lot of actually heavy lifting has been done, and so the current status of the notification is as such. So if there is a major deviation, there will be a notification directly on the pull request in GitHub, in our internal Mattermost chat system, where developer or the QA person can easily find the full report or exactly what was wrong with the run, which stage failed or which stage gave warning, and find out the stats for that. So, for example, the backtrace, if it's there, there's flame graphs, flame scopes, birth-top graphs, and similar things, SVGs that have been made that can help the troubleshooting if there's a big deviation or a big problem, let's say, or a leak or similar things. And the actual logs, of course, from those runs. So that should be also easily available. But what I'd like to do now is transfer it over to one of the Blues brothers there, Mr. Tomas, who actually does that daily, trying to he's trying to do anything and everything to stop a release. So all over to you, Corey.
All right,
thank you.
All right, yeah, so I'm Corey, I think the greenest member of the team, and basically that's my quick shop of the morning, trying to break Suricata there. So like Peter said, we have a couple servers, hardware, mostly Bash and Python scripts on the back end, and then we have GitLab runner kicking everything off. The whole setup really isn't too much different from standard CI, except like Peter said, the whole CI environment, most of it seems to lean towards like parallel workloads and Docker VMs, things like that. Since we have hardware, we can't really just go through the hardware and run 5 things on it at once for a single NIC. It's not too big of a code base. Basically, we're just building Suri, running it, maybe some custom tools, arguments on it per test. And then CI is doing most of the heavy lifting and just letting us know, hey, this didn't run right, or there's an error here or there. Can dive a lot into kind of how we set it up. Mainly, we have like a template we'll use to kind of limit the code down and everything like that, and just call sudo like YAML functions basically with all these custom parameters. Full pipeline, that's just one right there. It can take about 2.5 hours, and we only want to add more, more data, more tests. And then if you're not familiar with GitLab CI, it's kind of broken down into pipelines. So your single job, your stages, which are a line of jobs that will go one after the other, and then your jobs, as they call it, that are just the endpoint meat of the operations you're doing. First thing we have to do is dump out a bunch of debug info, basically. CI doesn't really tell you what's going on or what you kicked off. So we do that, and then immediately after that, we follow it by a serial wait, which is just a manual stage. If you click on it, it'll go, and then we have the API in the back end with a script basically kicking everything off. So once everything's done running, if it's all free and clear, you'll kick off the next workload so you don't trip over yourself. And then after that, you want to make sure you have everything you need. It's kind of like a DevOps approach. We just, hey, install everything. It's probably already there. It's just a one-time setup. Maybe if you nuke the box or rebuild or something, it'd be handy. But it's just kind of more documentation than anything. Of course, you need your libraries, PCRE, 2, 1, whatever it might be, JSON, pcap libs, things like that. Your compilers to build everything. Any tools or crons or custom stuff that your package manager aren't going to have, or that you're just kind of whipping up yourself, like trex, that doesn't really have a package anywhere I've found. Flame graph, things like that, and your OS config. So if you've ever tuned Suri before, you got to isolate cores, do things like that. We'll have different tests that do different things. So maybe on IPS tests, you got to split the cores up differently, right? Then the core file is something to note. I know Ubuntu has like an app port that they kind of overwrite the thing. So you just overwrite it with sysctl and go, oh, no, this is what I want. I want this core file, so you know where to find it. No trickery. And then you obviously have to build Suri, right? So we'll do this several times and say debug stage here, so you'll get more granular things, but the performance takes a huge hit, right? Optimize build so you can just peg it to all hell and try to get as much data through as you can see and make sure it's doing what you expect. And then ASAN's kind of its own beast, just to test memory leaks, things like that. Couple important things to note when you are building, what is it? Is it a PR? Is it a different branch? Or are you just pulling down a tar file and trying to build the thing? So we'll go a couple different ways to build that. And then we'll actually, filter on where is it coming from. So we can make sure, it's our code. It's not some random, URL with, Bitcoin miner on it or anything like that. And then obviously any special compile options like Peter was talking about. ASAN's full of them. Most of them are just like O3 for the optimized build. Then you actually have to configure it, right? So you want to clear out anything old, pretty obvious. Make sure your logs aren't there, your configured, your YAML, all that. And then reinstate your YAML, your rules. If it's IPS versus IDS setup, maybe tweak things a little bit differently. And then Trex, if you're doing a Trex test, same thing. Just kind of make sure the interfaces it's using are what you expect. Nothing too fancy there. And then you can finally get to the meat of everything, right? And these are kind of just in chunks, so we'll have different tests. And like I said, there'll be different stages of different builds in these tests. This one is just our generic Trex run, the kind of bootstrap one we came up with. So you'll configure Suri, obviously, right before this, and then you'll run it, kick it off, wait for the log to say, the threads are all created, and then kick off Trex in this case, and then you'll do a collect stage, which is really nothing more than just a wait. Sometimes you'll kick off, perf stat in there, collect extra memory, something like that, but for the most part, it's just wait. And then after that's done, it'll terminate Suri, control C it, basically. And then after that, you want to make sure Trex stopped or stop it if you have to. And then once you do all your tests, you get to the fun part, which is actually checking everything and analyzing the data, right? Most of what we do is a stats compare, and that is really just a Python script that'll loop everything and go over all the JSON stats. Get more into that later. And then the perf stats, so that's really just to check a few functions right now. For bigger tests, we'll compare all the top alerts. There could be thousands or 100,000 alerts coming through, and you can't really check them all. It's going to be too lengthy, so we just kind of check the top 500 or 1,000. And then generate any graphs if something, like stats are off or something like that. Maybe generate, this memory graph for version 5, 6, 7 in a Flame graph. And then we will compare any file checksums that Peter was talking about for specific tests. So now that things are hopefully settling down, you'll get a report stage, which is just an artifact at the end of the CI. So you'll get a full report or a failed one. The failed one's really just for if something broke in the middle of it, try to collect all that you can. That stage should always pass as long as you get to it. And your final check is really where to look once it's all wrapped up here. If you used GitLab CI before, that's what it looks like. The little exclamations just failed with or ran with failures or something like that. And then you can drill into those and actually look at what's going on. And you can download the report as well. You can kind of look at it through CI, but it's not that useful. You have to actually download it to get into the files. And that private warning there will throw a flag out there if something we know is private was looked at in a test, just so nobody, you're aware, you don't try to share it or anything like that. This is the stats JSON I was telling you about. Peter already was going over. If you, go more leeway, 10 or minus, plus or minus %, you'll have a warning thrown out at you. Is an improvement, though, is an issue. Like the other week, we had a flow fix that Victor put through. So that obviously a whole bunch of numbers went down. The memory was way better. And, we obviously knew, like, oh, yeah, that's a good thing. Sometimes it's not that clear cut. That's probably the hardest part about it is maybe some stats change and you're not sure why. You have to dig into it a little bit. This is the perf stat I was talking about. So Rust functions are usually what we'll check, and we'll just kind of, if it goes over like 0.02%, we'll throw a warning out there just to make sure nothing funky's going on. The file checksum's kind of straightforward. You just have two lists and you do a diff or a compare on them. Make sure that all the files came through. Those don't usually fail except for like older versions where maybe Suri didn't get this kind of file or these rules. And the top 500 alerts. So those will, if the alerts differed enough, it'll compare all the top 500. Sometimes it's 3 versus 2. It's not a big deal. Other times, maybe thresholds were going a little crazy or something like that, and you'll either have missing alerts or 20,000 versus 10,000, right? You want to look into that. Flame graph, that's what it looks like on the left there when it's kind of normal. I couldn't find one that was bad, unfortunately. But if it is bad, it just it looks like one of those is cut off in the middle, and then it's a big line going up. If you haven't used it before, it's a perf stat thing that generates an SVG, and you can drill into it, and it's really neat. And there's also flame scope, which I didn't get a screenshot for, but it's kind of the same thing, but way more granular. You can lift up, was it Node.js, I think, or a Docker container, and then drill into it. It's pretty neat. And special case, so seg faults, I'm sure people here have messed with. If you have a seg fault, right, you expect Suri to fail. So you can't really just run CI and have it go. You have to tell it, yeah, one, I want it to fail, and then catch it, so it's a little bit double work. But we'll, I think Peter was mentioning, we'll rotate through the cores and the builds, so we don't have a whole bunch saved on disk. But we'll do that. We'll get the core file from wherever it was, throw a warning, let everybody know, or in the test let it know, it failed. And then that leads into notifications, right? Okay, something failed, you have to tell everybody. We have a bot set up that'll do nightly PR runs, so 2, 3, 4 runs a night, since they do take about 2 hours each. And then we'll notify as soon as they're done, hey, this had a seg fault, or these stats were different. Pretty self-explanatory. We'll also, pipe it through into Mattermost. So failed jobs are a little more, concerning. The failed with warnings ones aren't really that bad. They're usually just alert that something finished. And I think I'm about done with time. Yeah, this is just our. Workflow, right? That we'll go into. Maybe ping somebody, tap them on the shoulder, let them know stuff's done. Recap, pretty much everything I just said. I'll skip over that. And tons of future options. So like Victor was saying earlier in his talk, different tuning things, different tools we could use, things like that. Q&A time? We have time?
No, you're out of time, but we can take a couple of questions. Just because we don't want to leave you guys out.